Imagine you are a cosmic architect. You have the ultimate blueprint of the universe in your hands, a set of rules we call the laws of physics. These rules tell you exactly how big a star can grow before it collapses, how fast it can spin before it flies apart, and how much heat it can generate before it blows itself into oblivion. For centuries, we thought these rules were absolute. But as we have pointed our most powerful telescopes toward the heart of the Milky Way, we have discovered something chilling. There are monsters lurking in the dark. There are stars so titanic, so violent, and so bizarre that they don't just push the boundaries of science. They take the rulebook and rip it to shreds. We are talking about stars that spin faster than a kitchen blender, stars that are millions of times brighter than our sun, and objects so dense that a single teaspoon of their material would weigh more than Mount Everest. These are the outlaws of the cosmos, the anomalies that keep astrophysicists awake at night, wondering if everything we thought we knew about the universe is fundamentally wrong. Today, we are taking a journey into the deepest, most dangerous corners of our galaxy to meet 10 stars that should not exist. From the nightmare fuel of magnetars to the impossible scale of hypergiants, these celestial titans are breaking every law in the book. Stick around, because by the time we get to number 1, you will realize that our quiet little sun is nothing more than a tiny, flickering candle in a room full of roaring forest fires. Let us dive straight into the deep end with our first cosmic rule breaker, Steve 18. Officially known as Stevenson 218, this is the current heavyweight champion of the universe. According to the laws of stellar evolution, there should be a hard limit on how large a star can get. Gravity and radiation pressure are supposed to reach a stalemate that prevents a star from expanding forever. But Steve didn't get the memo. This red hypergiant is so massive that if you replaced our sun with it, its outer edge would extend past the orbit of Saturn. Think about that for a second. Every inner planet, including Earth, Mars, and Jupiter, would be swallowed up inside the belly of this beast. It is 2,100 times wider than our sun. To put that in perspective, if our sun were the size of a marble, Steve 18 would be the height of an 80-story skyscraper. It is so large that light itself, the fastest thing in existence, would take 9 hours just to travel around its circumference. Scientists are baffled because, at this size, the star should be so unstable that it literally falls apart. Yet, there it sits, glowing with the luminosity of nearly 500,000 suns, challenging our very understanding of how much matter a single object can hold without collapsing under its own gargantuan ego. Moving from the impossibly large to the impossibly fast, we encounter PSRJ 1748-2446 AD. Just try saying that 5 times fast. This is a pulsar, the crushed remains of a massive star that has collapsed into a sphere only about 20 kilometers wide. Now, according to the laws of physics, a rotating body has a speed limit. If you spin a pizza dough too fast, it flies apart. If you spin a star too fast, the centrifugal force should overcome gravity and shred it into cosmic dust. But this pulsar is a speed demon. It rotates 716 times every single second. Imagine an object with more mass than our entire sun, compressed into the size of a city, spinning faster than the blades of a high-performance jet engine. The surface of this star is moving at about 24% of the speed of light. At this speed, the star isn't even a sphere anymore. It is squashed into an oblate spheroid. If it spun just a little faster, it should technically break the laws of causality and structural integrity. Physicists study this object to understand the very nature of matter at extreme densities, because the fact that it stays together at all suggests that the nuclear pasta inside it is the strongest material in the known universe. Next on our list of cosmic outlaws is the legendary Eta Carina. This isn't just one star. It is a binary system that has been throwing a century-long temper tantrum. In the 1840s, it suddenly became the second brightest star in the sky, an event known as the Great Eruption. Physics tells us that stars have an Eddington limit, a point where the outward pressure of the light they produce is so strong that it should blow the star's outer layers into space. Eta Carinae didn't just reach this limit, it smashed through it. It blew off a massive cloud of gas and dust, creating the famous homunculus nebula, but it didn't expire. It survived. Today, it remains one of the most luminous and unstable systems in the galaxy. It is millions of times brighter than the sun, and is constantly on the verge of a cataclysmic blast. It breaks the rules by staying alive in a state of permanent instability. It is a star that is essentially too bright to exist, yet it continues to roar in the darkness, a ticking time bomb that could go off any day and light up our night sky as bright as the moon. Now, let's talk about magnetars, specifically SGR 1806-20. If you think a normal magnet on your fridge is strong, you haven't seen anything yet. Magnetars are a type of neutron star with magnetic fields so powerful they shouldn't be physically possible. The magnetic field of SGR 1806-20 is quadrillions of times stronger than Earth's. If this star were located halfway to the moon, it would instantly wipe every credit card on the planet and literally rip the iron atoms right out of your blood. In 2004, this star released a flare of energy so massive that it physically affected Earth's upper atmosphere from 50,000 light-years away. In 1/10 of a second, it released more energy than our sun produces in 150,000 years. According to our models, a magnetic field this strong should be so warped that it would distort the vacuum of space itself, causing light to split into two and merge back together, a process called vacuum birefringence. This star turns the empty space around it into a crystalline lens, breaking the standard laws of electromagnetism as we define them on Earth. Coming in at number 5 is the strangest star you have probably never heard of, Przylski's star. This star is a chemical nightmare. Typically, stars are made of hydrogen and helium, with small amounts of other elements. But Przylski's star is packed with elements like holmium, dysprosium, and even radioactive elements like plutonium and berkelium. These are elements that usually only exist for a short time in a laboratory or as the result of a supernova. Seeing them in the atmosphere of a living star is like finding a modern smartphone inside an ancient Egyptian tomb. It shouldn't be there. Some scientists believe this star might be a sign of something even more exotic. Perhaps it is concentrated dark matter, or the result of a nearby neutron star collision that happened in the distant past. It defies the standard solar model so thoroughly that some astronomers have even jokingly suggested it could be a site of extraterrestrial nuclear waste disposal. While that is unlikely, the fact remains that this star's chemistry is a giant middle finger to everything we thought we knew about stellar composition. Number 6 takes us to the edge of the galaxy to meet the hypervelocity stars, like HVS-1. These are stars that are literally being kicked out of the galaxy. Physics says that stars are supposed to orbit the galactic center in a predictable, stable path. But HVS-1 is traveling at over 3 million kilometers per hour. That is fast enough to escape the gravity of the Milky Way entirely and drift into the dark, empty void between galaxies. How does a star get that much speed? The only way is a gravitational slingshot from the supermassive black hole at the center of our galaxy. It is a cosmic game of billiards where a star is the cue ball. The sheer violence of the forces required to accelerate a massive star to these speeds is mind-boggling. It breaks the law of galactic containment, proving that not even a galaxy can hold on to everything it creates. These stars are lonely travelers, destined to spend eternity in the absolute nothingness of intergalactic space, far away from any neighbors. Let's shift gears to the undead star, officially known as SN 2014 AD. This is a Type 1X supernova remnant that simply refused to stop shining. In our standard physics models, when a white dwarf star reaches a certain mass, it undergoes a thermonuclear runaway and blows itself to bits. Case closed. But SN 2014 AD didn't quite finish the job. It was a partial supernova. Instead of being completely obliterated, a chunk of the star survived and became what scientists call a zombie star. This object is now hurtling through space, glowing with an eerie, distorted light. It breaks the law of stellar mortality. It proves that a star can undergo the most violent event in the universe and somehow come out the other side as a mangled, radioactive ghost. This discovery forced astronomers to create an entirely new category for stellar events, acknowledging that sometimes the laws of physics are more like guidelines. Number 8 is the Thorne-Zeitkow object. Now, I have to be honest with you. This is a star that sits inside another star. Imagine a massive red supergiant that has swallowed a tiny, dense neutron star. On the outside, it looks like a normal big star, but deep in its core, it is powered by the gravity of the neutron star rather than nuclear fusion. For a long time, this was just a theoretical what-if in physics papers because the physics inside such an object would be incredibly complex and unstable. But in 2014, astronomers found an object called HV 2112 in a nearby galaxy that fits the profile perfectly. It has a chemical signature that can only be explained by the unique processes happening in a Thorne-Zeitkow object. It is a nesting doll of cosmic proportions. It breaks the law of stellar structure, showing that two completely different stages of a star's life can exist simultaneously in the same body. It is the celestial equivalent of a human being with the heart of a cyborg. Next up is the hyperluminous X-ray source known as M82X2. This is a pulsar that is shining far brighter than the laws of physics say a pulsar should be able to. We talked about the Eddington limit earlier, the threshold where light pressure pushes away the very gas the star needs to shine. M82X2 is over 100 times brighter than its limit. It is like a person trying to drink from a fire hose while the water pressure is so strong it should blow their head off. Yet they keep drinking. Scientists were so confused by this that they originally thought the object must be a medium-sized black hole. But when they detected the characteristic pulse of a pulsar, they realized they were looking at something much weirder. It turns out that the magnetic field of this star is so intense that it actually changes the shape of the atoms falling onto it, making them thinner and streamlined so they can pass through the intense radiation pressure. It is literally cheating the laws of physics by reconfiguring the building blocks of matter. Finally, at number up is the star that seems to be older than the universe itself, HD 140283. Better known as the Methuselah star. According to the measurements of the cosmic microwave background, the universe is approximately 13.8 billion years old. However, some early estimations of the Methuselah star's age put it at over 14 billion years. Now, obviously, you can't be older than your own mother. This paradox caused a massive stir in the scientific community. It suggested that either our understanding of the Big Bang was wrong, or our understanding of how stars age was flawed. While newer, more refined measurements have brought the star's age down to just under 13.5 billion years, it is still cutting it incredibly close. It was born just a heartbeat after the beginning of time, and its existence at such a high age and high speed through our galactic neighborhood makes it a living relic. It is a star that has seen the birth and transition of almost everything in the cosmos, and it remains a constant reminder that our timestamps for the universe is still a work in progress. When you look at these 10 objects collectively, a pattern starts to emerge. We often talk about the universe as a machine with fixed gears and predictable outcomes, but these stars show us that the universe is much more like a wild, untamed wilderness. Wherever there is a law, there is an exception. Wherever there is a limit, there is something trying to break through it. The existence of these stars isn't just a curiosity for people with PhDs. It is a vital clue about our future. By studying how a magnetar warps space, or how a Thorne-Zeitkow object functions, we are learning about the fundamental limits of energy and matter. This is the kind of knowledge that could one day lead to breakthroughs in power generation, propulsion, or even our understanding of gravity itself. The laws of physics are really just our best guesses based on what we have seen so far. For most of human history, our data set was limited to what we could see with our naked eyes. Then came telescopes. Then came satellites. And now we have instruments that can hear gravitational waves. Every time we upgrade our senses, we find that the universe is weirder, bigger, and more lawless than we ever imagined. The zone of avoidance, black holes. And these extreme stars are the front lines of human knowledge. They are the places where the math breaks down and where imagination has to take over until the observations can catch up. Think about the sheer energy involved in these objects. A pulsar spinning 700 times a second is an engine of pure power. A magnetar is a treasury of magnetic energy that dwarfs anything we can conceive of. These stars are cosmic laboratories where nature is performing experiments that we could never hope to replicate on Earth. We are just the observers, peering through the keyhole of our telescopes, trying to make sense of the madness. And the more we look, the more we realize that the Milky Way is not just a collection of pretty lights. It is an arena of titans where the most extreme versions of reality are playing out every single second. This brings us to a profound realization. If these stars can break the rules, what else is out there that we haven't found yet? We have only mapped a tiny fraction of our own galaxy. There may be stars made of even weirder stuff, such as quark stars or preon stars, hypothesized objects that are even denser than neutron stars. There may be dark stars that don't emit any light at all, powered by dark matter collisions. The laws of physics aren't a cage, they are a map. And as we explore further, we find that the map has terra incognita written all over it. These extreme stars are the landmarks telling us that we are heading into the unknown. But why should we care? Why does it matter if a star 50,000 light-years away is spinning too fast? It matters because we are part of this system. The atoms in your body were forged in the hearts of stars just like these. The carbon in your DNA, the iron in your blood, the gold in your jewelry, all of it was born in the violent, law-breaking events of the cosmos. By understanding these extreme stars, we are understanding our own origin story. We are the leftovers of a stellar rebellion. We are the products of cosmic chaos. Every time a star like Eta Carinae erupts, it seeds the universe with the elements of life. Every time a pulsar spins, it sends out a signal that helps us map the galaxy. The universe is not a static place. It is a process. It is a continuous explosion of creativity and destruction. These 10 stars are the highlighters of that process. They show us where the action is. They remind us that the sky is not a ceiling, but a vast, open frontier. We live in a golden age of astronomy. Never before have we had so much information about these outliers. And yet, the more we know, the more we realize how little we truly understand. The refusal that I mentioned in previous discussions isn't just about scientists avoiding hard topics. It's about the fact that sometimes the universe is so loud and so bright that it is hard to hear anything else. So, when you look at the night sky tonight, try to find the Great Square of Pegasus or the Belt of Orion, but also think about the things you can't see. Think about the zombie stars hurtling through the dark. Think about the magnets so strong they could rip the iron from your veins. Think about the stars that are older than the universe they inhabit. It is a terrifying and beautiful thought. We are tiny, yes. Our lives are short, yes. But we are the only part of the universe that is looking back at itself, trying to figure out the rules of the game. And even if the players are breaking those rules, the fact that we can even recognize the cheating is a testament to the power of the human mind. Space is hard, it is dangerous, it is indifferent to our existence, but it is also the ultimate mystery. The zone of avoidance, the great attractor, the Methuselah star, all of these are chapters in a book that we are only beginning to read. We have only turned the first few pages. There are billions of stars in our galaxy alone, and billions of galaxies in the universe. If there are 10 stars in our neighborhood that break the laws of physics, imagine what is happening in the billions of other neighborhoods we haven't even looked at yet. The possibilities are truly infinite. Some people find this thought scary. They find the vastness and the violence of space overwhelming. But there is also a great comfort in it. It means there is always something new to discover. It means that no matter how much we think we know, there is always a surprise waiting for us around the next galactic corner. The universe is not a solved puzzle. It is a living, breathing mystery that invites us to ask why and how every single day. And as long as we keep asking those questions, the stars, no matter how extreme or law-breaking they are, will continue to light our way toward a deeper truth. We are entering a new era of space exploration. With missions like the James Webb Space Telescope and upcoming observatories like the Extremely Large Telescope, we are going to get much clearer looks at these outlaws. We might find that some of them aren't breaking the laws of physics at all, but rather revealing new laws that we haven't discovered yet. We might find that the zombie stars and nesting doll stars are much more common than we think. We might find that the universe is even more crowded with anomalies than we ever feared. And that is the most exciting prospect of all. As we wrap up our journey through these 10 extreme stars, remember that the extremes of today are often the normals of tomorrow. Just as the idea of black holes went from a crazy mathematical theory to a proven reality, these law-breaking stars are paving the way for the next revolution in science. They are the heralds of a new understanding. They are the beacons that signal the end of our cosmic ignorance. So stay curious, keep looking up, and never stop questioning the rules of the universe. Because as these stars have shown us, the universe certainly doesn't feel obligated to follow them. The Milky Way is a vibrant, chaotic, and utterly beautiful home. It is filled with mysteries that we are only just beginning to scratch the surface of. From the Titan Steve 18 to the ancient Methuselah, these stars are our neighbors in the vastness of space. They are reminders of the power and the complexity of the cosmos, and they are an invitation to keep exploring. The next time you see a normal star, remember the monsters in the dark. Remember that out there, somewhere, the laws of physics are being broken right now, and it is arguably the most spectacular show in the universe. Science is a journey, not a destination. These stars are the milestones on that journey. They tell us how far we have come and how much further we have to go. They challenge us to think bigger, to dream further, and to never settle for simple answers. The universe is a complex, beautiful, and lawless place, and we are lucky enough to be here to witness it. So, as we conclude, let's take one last look at that hypothetical museum door. It isn't just empty space or dust behind it. It is the future of our understanding. It is where the next 10 law-breaking stars are waiting to be found. And when we finally open that door, who knows what wonders we will see? The cosmos is waiting. And the laws of physics? Well, they were made to be broken. Stay fascinated by the stars and keep searching for the truth hidden in the light and the dark. The universe is much more amazing than you have ever been told.